Hello? Yes, okay, hi. Welcome back to ABI-DOS. Thought my mic wasn't working for a second, but it is. Last episode, we started on Neuralink Conflux. We didn't get very far. Yeah, this might be the biggest project yet. I have an idea, but it is one that is extremely outrageous. It is a iterative thing. I don't know if I wrote it down somewhere. I think I did. Yeah. Um, the idea is to not read all the numbers in a certain row, but to read until the first green, then continue reading down the chain, and then once a chain is complete, read back upwards. And this probably will work, hopefully. Uh, this requires well, not some, but a lot of extra stuff. I feel like at this point I'm not building a machine. I'm not even building a. I'm not even building like a circuit board. This is a circuit board. This is what it looks like a circuit board to me, because you know you got a lot of the same thing going in. But I think I'm building a factory. So yeah, I'm gonna build multiple different machines to help work on different functions, and they are all supposed to come together to accomplish this final task. Yeah. So one of the machines I know I have to build is one I've done before, but it is one thing that I've taken very long to build. It is Stack Compiler, I believe. Yes, this is one that this is one that I remember I didn't solve this on my own. Yeah, I didn't solve this on my own. In fact, I looked at someone's solution for it. Yeah. So there you have it, I guess. I looked up a solution for this thing, which means that if I use this on my solution, does it not count as the same? I don't know. Is it some Ship of Theseus type thing? I don't know. I think I mentioned Ship of Theseus in this game before, but surprise, surprise, it's happening again. Alright, so yeah, this stack compiler machine is what I would like to use for my machine here. The reason why is because the overall goal is to first read green in layer 0, then read in layer 1, then read in layer 2, then read in layer 3. Once I'm done with layer 3, I'll read back in layer 2, then back in layer 1, and then back in layer 0. Which means that we're basically pulling things forward and backward and forward and backward. And what better machine does that than Stack Compiler, which will in fact... it's actually really hard to see here, but you see that things get pushed forward and forward and forward and forward. And when a machine happens, they all get pushed back by one space. And that is the machine that I would like to have occur. Yeah. Fortunately, because we only have 4 layers, I'm pretty sure I only need to have 3 of these instead of 4. So it shouldn't be too big of an issue trying to rebuild this type of machine. Yeah. You only need 3 and not 4. Okay. 3 and not 5 or 6. The reason why it's 3 is because we will have one that holds the value in layer 0, one holds the value in layer 1, and one holds the value in layer 2. The reason why I want to hold that value in the first place is because when I come back to the layer, I want to start from where I ended. So when I finish layer 2 and I move to layer 3 and I'm done with layer 3, I'll come back to the last point in layer 2 and continue from there. Once I'm done with that layer once I'm done with layer 2, I'll go back to layer 1 and continue from there. So that's the idea of pushing in layer 0, then 1, then 2, then 3, and then pulling out the most recently added object. And fortunately, we will have some space. We'll have a lot of space for this. So it's not going to be too much of an issue. So yes. Okay. So I guess we'll start working on the machine first. I already have like an idea in my head of how I want the machine to look like. It's going to be looking exactly the same as the machine here. Honestly, it's not really going to be looking that much different. It's going to look like this. That's all it is. So the entrance point is here. I mean, I probably should have did this upside down. If I did this upside down, I'm going to have to flip it this way. Honestly, it doesn't really matter the orientation I do it in. But okay, these are the 3 spaces where 3 things will be held. 1 for each layer, 0, 1, and 2. Alright, if 0 goes in here, and then we hold something from layer 1, 0 will be held in here, and then the layer 1 will be held here. And then we go to layer 2, the layer 0 will be held here, then 1 here, then 2 here. And then once 3 is finished, this 2 will be pulled back. So after 1 is done, it will just simply go back to here. And then there'll be something that pumps this value down here, and one that pumps this value out to where it needs to go. Yeah, this is what this should look like. And I want to hook this up to basically the green checker, which we've already built. In fact, the green checker can actually be a lot more relaxed now that I think about it, because we're going to read these one by one. We're not going to read all 10 at the same time in a row. So, alright, we will start with signal 1, because signal 1 will give us our very first value. The way we do this is we do the usual, we multiply by 10 and then we read like that. So signal 2 will be set to this value. If we went to a better test case, I think 5 is the ideal test case we've had so far. It will just shift the position to 40 because signal 1 says 4. Okay, that is what we want. Then we want to start immediately pumping out values from signal 2 and start hooking any green ones into this machine. But of course, we probably have to do some other stuff before that. Now we need to really consider exactly what we want first. Besides the value itself, not sure the value itself, we actually just want the color, really. But I also want the position number, which means actually, what I probably want to do is, I will probably... I can choose to call signal 2 from here. I can either push it forward immediately after calling, or not push it forward immediately after calling. And this will change a couple things, but I think if I want to optimize it, I'll have to see which option gives me the least extra stuff to do. Yeah, okay. So this looks like what I want. Now what do I need to have from here? I'm gonna have a very big amount of space before hooking it into here because I know there'll be a lot of things I need to do beforehand. I'll need the green checker, obviously. So really, the green checker is not that difficult. A green checker will allow things to pass through, otherwise things will not pass through. So we'll do this, basically. And throw away all the white ones, or the white ones we don't really need to care about. If we do call this forward, then we need to take the position of the green checker, which will be this, and subtract 1. Otherwise, we just take its value. But if we don't shift the pointer forward after calling, then at some point after this step, we will need to shift the pointer forward manually. So it really depends on what I choose to do. Let's say I just choose to push forward normally, and then I read and subtract 1. So this is what I get. If it's green, it will pass through, it will read the position and subtract 1 for its actual position. Then the row number is obtained by taking the mod of 10, but I do know that there are other things I need from this value. For example, I need its actual current position, because I need to know the row it came from. Meaning, I need to have a separate value held here. And that is what this will be for. This holding area will hold the position, which means that we don't immediately take the ones digit, which is what you get when you mod 10, and you shove it in here. Instead, that ones digit must be in a separate area, which means we duplicate. So 40, which is this value, gets thrown in here as this, which will next dictate exactly what row in N1 will do. So this 0 means that we'll read from row 0 in layer 1. And then if it's white, we will have to call out until we get a green. It's green where something interesting happens. So if it's a white, nothing happens, which means we need to do some calling out. So if we go to another case study, which is this one, we start at 90. Oh, we already start at green. Alright, so I need to find one that starts at not green. Yeah, sure. So this will basically throw out everything that isn't green. When you get to 75, you get a green value. It'll be set to 75, you get the original position here, and you get the row number here. Cool. This is already a lot of bits, but hopefully we get to reuse the same thing. The reason why I would like to reuse the same thing is because the step to go from 0 to 1 is the exact same as the step going from 1 to 2. And because we are doing this iteratively, I don't know if I'm using that word right, but I think we are. The way I want to do it is, I want to make it so that every time we read a green, we immediately go to the next step, which allows us to basically do everything one at a time, which I also think is what is meant here when it says independently. Yeah. Okay, so this is the row number. What I would like to do next is send it in again. I want to read from this 5. So I want to basically add 10. So I want to add 10 and then call out this value, but the adding 10 is kind of a problem, right? It's like this. I want this to be here. I basically want you to add 10 and then multiply by 10. But there are a couple problems with this. If we went to layer 2, we need to add 10 twice. And how are we going to have that happen? So this will bring you to layer 150, and then you'll get the same thing reading over again. When you reach this value will be held here. Of course, we do need this to move out of the way. So I suppose it's more so that maybe like a B sensor has to be here. That will basically do this sort of thing, maybe? I'm not entirely sure. I sort of like I want this to happen. Yeah, and then when the next thing comes in, which will be here, this will cause these two to be held in this order. And basically when this gets released, this will come back to, I think, this path here. And we'll continue reading from here, I think. Yeah, but see here we read 130, even though we're supposed to read 230. Because we are going to the next layer, which is layer 2. So how do I program this to read from 130 to 230? I think there are a few ways to do it. One of the ways is that before modding 10, you will actually get a certain value, which is this here. If I divide by 10, and then I add 10 to the tens digit, that might make things a bit more interesting. Not 10, but 100. So rather than mod 10 immediately, I want to duplicate again. Okay, we'll move this all the way on top, just so we won't block the way. Then instead of adding 10, we add 100. This should allow us to do some interesting things, right? So this will give us 175. No. Wait, we also take... Wait, hold on. Hold on. We need to divide this by 100 first to get the divide by 10 first to get the tens digit. If I divide it by 10 first, there'll be remainder involved, but we'll get everything after the tens digit. But is adding 100 valid? So we get the 7. If we add 100, just get 107. That's not good. Why do I want the 7? No, I want to divide by 100, I think, to get the 100th digit. Because the 100th digit determines which layer it's in, not the 10th digit. So if I divide by 100 here, I'll get 0, because rounding down, you get 0. Adding 100 gives you 100. So this will give you the layer, this will give you the row number. We have to multiply this by 10. And then we merge them, which is going to do something like this. And then we can actually just read into here, because we don't need to multiply by 10 anymore. So this should give us the value correctly, which is 150. If I change the direction here to point up at all times, yes, this should in fact cause us to read at 150. If we then continued, we will then be able to read at the next value. So this will divide by 100, give you 1 exactly, because rounding down gives you a 1. adding... Oh, I don't want to add 100 to that, do I? No, I want to add 1 then multiply by 100. Oh, that's a lot more steps than I remember there being, but it should still be fine. I don't want to add 100, I want to add 1 to the 100th digit. So I add 1, then multiply by 100. So we'll take the 100th digit from here, add 1 to it to increase the 100th digit, then we multiply the 100th digit again to the 100th digit's place. And this should give us the actual correct value. So we start off here, we get 150, which is correct. Next, this will go from 1 to 2, and then 200, and we'll be reading at position 230. And then, we'll start reading here, we'll be at 234 at this point. This will hold on to these. And it is at this point where we will start reading the 300, or layer 3. That's where things change, I think. But how do we determine how that changes? We must have a step prior to pull out anything from layer 3, which I think can be activated by something that checks for the value 300 or greater here. That seems good to me right now. Okay. And then at the very end, I didn't really inform you of this, but at the very end I want a checker for a position 9. So at this point here, we'll get the ones digit. If the ones digit ever says 9, we're basically done because we've read the last thing. That will signal for this to turn back, which I think is what I want. Yeah. Okay. Let's see if I can... So here we're gonna get something very awkward. We're gonna get these to all just merge a little bit, and yeah, you get a big problem here. So at some point in the previous section, or at some point before this, we would have wanted the ability to pull out. So I guess we'll just have it be here for now. I'm having it be very messy, but hopefully it doesn't really matter. So we'll pull this out, and this will be controlled by whether this value in here is a 300 or not, which means we're checking for if that value is greater than 299. If that value happens to be greater than 299, it will pull out this value, which we know is going to be green because of this checker. This value can then immediately take the ones digit off and read from here. So we read the ones digit, we set the pointer of signal 3 to be at that position, and then call it out, probably without moving it around. I don't think it really matters. But by principle, it shouldn't be moving around after calling it out. So this 3 will then, you know, it will just add a value to an accumulator. Like that. Right now, I'll just leave it at the accumulator. And of course, after this, you'll need to continue reading. Which is why after this, I'll probably read another 2 again. So let's just assume that this happens. And then we'll just run it through for now. We'll just see exactly what's going on here. Okay, yeah, because this 2 is called out so late in comparison to this, these two are so close together while this and this are so far apart that I think it's fine. I don't think there'll be any timing issues. So now we have the layer 1, layer 0, layer 1, and layer 2 items here. Layer 3 comes in next. This will activate this. So when this comes in, you get this. And that will actually, in fact, call out the value 1 and put it in the aggregator. We'll then continue calling out 341. 342 is activated. 342 moves the signal to position 2, calls that out, and then continues on. Yes, okay. I think that's really interesting because then my mod 9 checker has to occur in 2 places. It has to occur here and here. Is that okay? I mean, I guess I could code that in. I just want to know if it's okay or not. I think it should be okay. I think. I'm not quite sure. But yeah, here you'll see that... Oh, we go to the next step. Oh! Well, the mod 9 checker also has to occur here. Yes, because we're not checking the green values, we're checking all values. So does it have to occur even further before? Maybe. In that case, then why don't I already have all of this come before the green checker? Well, because this needs the hundreds digit. This needs the raw value here. If we need the raw value here, then there will be a problem. Although not entirely. There are some ways we can flip things around. Okay. So we immediately want a 9 checker pretty early on. Is that our idea? I think it is. There are other ways to collect this value. And that way is basically just have this set up here. This is the only other place we need to collect the actual raw data as to where the green mark is. So what are we doing? So what are we doing? We'll move this down closer to here. This turns right by default, so we have one that turns left. No, we have one that turns right if it's not green. If it's green, then wait, no, it's like this. This will turn right if it's not green, but if it's activated, it will turn left. But beforehand, I need a lot of things beforehand. I need to both collect the position, take the mod 9, take the mod 10 for its ones digit, then check for the value of 9. So we want to do that. Okay, on this wire to sort of be out of the way first, I'm just gonna thread it through here. Because all of these are calculation based, we don't actually need the calculator functions, we don't actually need to worry about the red wire going through them. In fact, this entire place is completely fine for wires. But this wire will actually change things, right? It'll basically activate all of these. And I think we want to do it twice. Like one to release and one to activate these guys. Is that fine? Like, let's say I do this. Then the first one will let go of these guys. The second one will activate these portals to send them backwards. I guess it looks fine for now. Okay, but we have other things to work with here that's problematic. We definitely want to... Because right now we're only going to get the 9's digit. Or the 1's digit. So this is the 1's digit, which is 0. We'll check for green. If it's not green, it gets thrown away. And we'll continue. Here we'll get the 1's digit, then the 2's digit. In fact, it makes me think like, why am I even doing this if I can just count from 1 to 9, but I guess it's fine. It's fine. This works for now. And then we'll check for something that's green, which is the next one. The next one will come in here. This is where things get interesting. Because this 5 and this 5, oh, these two are different. Ooh. This needs its actual position. This needs its actual position. So the way we handle this bit coming in is going to be very different. Okay. Alright, let's get rid of all the wires first. I need to rewire a lot of things. Rebuild a lot of things. Because now our priorities are a bit different. Alright. You wire can go back here so that you don't disturb me when I'm working down here. This thing can also stay because it's supposed to stay. Oh, I said stay. Okay. So this middle section is the one that we need to worry about. Now we no longer need this or this. Well, no, we still need to read. We still need to set a pointer at 3 to this position, so yeah, this is still required. I'm just gonna run this all the way here first so that I don't get confused by what bit goes where. Okay, so at this point, what's coming in here is the 1's digit. We need a few things. We need the position of the actual pointer and the hundredths digit of that. So we will duplicate. One of them will provide its raw value. The other will provide its positional value. Okay, this one I'm just gonna hide it here. We don't actually need to worry about this. This is the accumulator, that one we can leave. This one we can just hide in the corner as well. We will use it later. Now I wanna just deal with this. So raw value can go up top. can be the ones digit, sure. The one that is useful is this, which we will need to once again read the position of the pointer and then subtract 1 for its actual position. Makes me think that maybe I don't really want to call, but I want to just keep its position. Then we get a couple of things though, like before this we need to pull. I mean, that should be fine, right? Okay, let's do that. Let's sorry, I'm like very not right today, but let's do that, right? Let's make it so that when this thing gets called out, it does not get pushed over, but there needs to be an actual forward movement of the pointer for it to count. So this will actually push forward the pointer by 1 before calling. So this will read, yeah, no. This should not call yet. Interesting. Wait, hold on. That's a bit interesting. So this will read position 0, which is correct. This will push forward by 1 and read. This will push forward by 1 and read. This will push forward by 1 and read, and then we'll reach 75, and then things will go fancy there. I feel like this is a bit more complicated than I intended it to be. We'll get 5 as the raw value, we'll get the 75 as a not so raw value. Positional value. 75 has 2 different things it needs to do. Okay, the 2 different things it needs to do are, firstly, it needs to produce the hundredths digit. So we divide by 100. These steps are all still the same. Divide by 100, add 1, and then multiply by 100 again. That is not multiplying by 100. This is multiplying by 100. And then they'll merge after this. The ones digit and this digit, whatever, will merge. And things will happen. The other one will go into this. Yeah, the other one will go into this chamber here where it's held. Like so. So like that, I think. So if it's green, it pushes forward. If not, it pushes forward. If not, it pushes forward. If not, it pushes forward. Blah 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 blah. We have a lot of space here, so actually the pushing forward can occur in here. Whatever we need to do can also be occurring here. That's fine. So here we duplicate. These values will merge. You get 105. This needs to multiply by 10 because the ones digit here will become the new row number, which is the tens digit. And then we can do a pushing forward here, which will be activated once by this bit. So we'll push forward. Let's actually need to push forward by 1, honestly, because because we're supposed to read here anyway. Like, there's no need to push forward by 1, right? We're gonna read the value anyway. So like, it's gonna go to the 1 digit of the next value. So like, why in the world do we need to push the value forward by 1? It's redundant. It's pushing forward by 1, but then the pointer is getting moved away after that. So the push is not doing anything for us. 150, yeah, immediately gets pushed here. So what's the point of pushing forward? No reason. And then we'll continue reading from here, and then everything should still work out fine. Okay, cool. In fact, I can probably make this step. Actually, I don't know why I can make this step a little more of. I feel like this looks very inefficient, but we'll see. We'll see if there are any issues with the space later on. But I feel like this is kind of good as to what I want so far. So we'll have this, we'll read 150 and we'll start reading that, and then at 153, looks like, we will get in the next bit. We'll go in here. These will be released by something. Aha! So what releases this? Probably, I mean, whatever I want, like here should be fine. And I want to release this and this. And then this blue wire will be releasing all of these. Yeah, okay. Honestly, it should be fine for now. I don't know if there's a real requirement to... Okay, I do realize that we might have a problem with this thing over here. When this comes back here, I want it to be still facing rightwards. There's more so I want this to have a straight line going to here. So you can see when this comes in here, there'll be an automatic turning rightward anyway. So that's fine. So this will come in here instead. Okay. This didn't really change much of the solution. Yeah, okay, we're fine. We're fine, we're fine. So, alright, we'll continue reading this. 150. This beat should hopefully release at the correct time. It can be earlier, I think. It doesn't have to be... Yeah, okay, it can be earlier. We'll get to 230. Good. Then we will get to 340, I believe. Because 4 is green, yeah. 4 is green. Get to 340. And now this will change because we have read a number greater than 299 or 300 or greater. So whenever a green thing comes in here, it will do this. Read. Call out. This should probably not push forward. Does it matter? Not really, actually. What? Wait, what? Oh. Hold on. Yeah, it should push 4 before reading 2 and not moving. Okay, I see. Yeah, we should follow the same set of steps for all of these. Okay. So all of these should follow the exact same procedure. Okay. Just to make things simple for myself, I'm gonna put a breakpoint here so I can immediately skip to this point. Here. When a 0 comes in here, this is for position 340. That will add 1. Then we'll read 341, which won't fail. We'll read 342, which will pass and add a 0. We'll read 343, which will pass and then add also... I'll add a 1, okay. And then we'll continue reading until it reaches 9. And that's where things get interesting again. Right? I think so. I completely messed up because I went way too far. Okay, so at that point, I want to release all of these guys. Then we'll have to do something with this value over here, which is the... In this case, it will be layer 2, right? Yeah, in this case, it will be layer 2. So I'm gonna basically breakpoint until I read 348. And then we will see when 349 comes in, these will be activated. So these guys will be activated, everything will be pushed back by 1. 342, or 334, which is where we last left off, is what's gonna happen. I feel like when I have the 9 here, I shouldn't just keep reading this. I feel like a 9 has to be specifically pulled out to do multiple things. Okay, so instead, why shouldn't a 9 instead of activating these it should instead get pulled out and then activate things on its own and I get thrown away without reading these. Yeah. Okay, so here we will do multiple things. So there are a few things I would like to change about this right now. Because this wire works so much better if it's connected to this, I want this to be on the bottom side. Which should be fine, honestly. This can just be completely mirrored. There should be no problem. Okay, so this set will be up here. This will turn around and go this way. Whereas this will be here. And then something like this happens. We'll leave some space in case we need space. But yeah, so the 9 here can do a couple things. It will activate these guys, for which it needs multiple hits, I guess. There you go. We'll do that. Then does the 9 need to do anything else? Because if it does, I'm just going to throw it away. But if it does, we have space to deal with it. The next thing I want to do is to have some way of getting this to where it needs to be. Because what is this value? This is where we started off from the previous position, right? So it's kind of like I want to send it back here to the reader again. Interesting. Okay, I can do that. It's not that difficult to do, in fact. All I need to do is to just pipe it in. But of course, because we've already read the position here, instead I want to add 1 before piping it in. So we'll add a conveyor that pushes this all up into here. We'll just add 1 at some point, and then hopefully this all works out right now. So we'll set to U. Whoa, we messed up somewhere. Yeah, these are not green. Hold on. Right, these should be turning around like that. Nope. Okay, hold on. Let's settle this properly. These go right by default. Green should make this not active so they go right. Okay. Is this right now? There you go. 75, 153. Yeah, these are the numbers I remember. Okay, so when 9 goes in here, 9 gets pulled out. They will activate this and then send everything backwards by 1. 234 becomes 235, which is red here, and the cycle continues. Yes. Okay, looks good. So we'll continue from where we left off in layer 2. And then there will be nothing here. When a 9 is checked again, that's the end of this row. That's very nice. 75 gets pushed back, 154 gets sent in. We'll read from where we left off in layer 1, which will also have nothing. So at layer 9, we'll send back to position 75, or position 76 because we had 1. Yep. And then at position 76, we'll be at row 7. Do we read multiple times here? Yes. Yeah, so we'll do this over and over again. And at the very end of this, we will get a lot of numbers, which I piped all into here. Honestly, I think we already used a lot of space here, but it looks like we are working very well right now. Looks like. I hope nothing too problematic is going to happen after this. But yeah, okay, I can definitely see things going very well here. I can see if I can tidy up a little bit. So, this will instead connect to the U. Red wire here, I can just send a red wire like this to save space. This will look like this. The B's will go here before throwing away. And these B's will definitely just pipe into here. Okay. If I really want, I can just send this all from this side because we can save space. In fact, this probably is where we're going to deal with the final step, which is what we have accumulated so far. So the question is, have we accumulated everything correctly? If we go back to 0, at the very end, we should see, according to this example, the value of 3, right? No, the value of 1, the checksum. So at this step... What? Oh, I should... Yeah, I need to go... Ah, jeez, okay. Yeah. Okay, so... I guess we'll start. We'll just watch the entire program run because... Yeah. So we'll watch the program run. So when a 2 is sent in, you get to this next position, which will keep reading. This is going to be really slow, but I just need to make sure it works out. Okay, so here at this step, it will read position 127. And it will read 270 as a result. Good. 270 will read this 272, which will then read at position 320 because 2 is red as a 1's digit. 270, okay. 323 is red, so the 1's position is 3. It will send in that value, which is a 0. Okay, and it will continue reading. At this point, nothing happens. So when the 9 is red, this will all get sent backwards. This 272 will get thrown in as 273 and continued reading on. Yes. Alright, let's continue. Sorry, I was hung up. I was held up with something. Okay, so yeah, when we read 273, we go back to this position and we continue reading. So here we will just keep reading until... Well, we'll reach position 9 again because nothing to be read here. Okay. And then we will release the 127, which will then read as 128. We'll read from there. From 128, there is another thing we read, right? Yeah, which is position 9. Oh... That's a problem. That's a problem. 9 is thrown out first. The 9 shouldn't be thrown out first, right? No, no it shouldn't. No, it should not. Oh gosh, that's a big problem. Where do I fit this part? Do I fit it after the color? No, but the 9... Okay, crap. If it's... No, there has to be a checker before. Okay, I think I see it. But do I see it? Because this 9 is going to be here. Yeah, okay, I see the big problem now. We've completely forgot to check if this 9... We're just throwing away all the 9s, but if the 9 was useful... Yeah, okay, I see a problem. Okay. Well, we can maybe fix this. The problem is that if this... There must be a checker beforehand. So it's not... Okay, so the green checker comes before the 9 checker. But the green checker does different things, doesn't it? Then along this line, I can actually do like a 0 checker here, which honestly works way better because when this 9 comes in here and checks as a 0, it basically also it works the same as here. Okay, it's fine, this is still fixable. We just need to make it so that this comes first before this. Okay, let's get rid of you for now. We check for green first. If green is right, you push forward. So yeah, this is fine. And we check for 9. Okay. There's a bit of a spatial constraint here, but we should be fine if we just pull this down. But there should be a 9 check here as well. There should be a 9 check on both sides. Ooh, ew. Yikes. Wait, no, the 9 check should be only when there's nothing here. Oh. Oh, okay, if it's green, then we throw it in no matter what. Right, I remember that. Yeah, I don't know why I didn't figure that out. But okay, yeah. So it's more of here where I need to do things. Okay. So I check for 9 here. Check for 9. And then the conveyor is here. If 9 is correct, this will activate and do the necessary things. Okay, I'm gonna pull this all out first. We should just have as much space as possible. So this 9 will activate the 2 Bs, which are here and here. That will activate this and throw away. Otherwise it goes down this way and does the same. Okay. Okay. Otherwise if it's green it just gets thrown up here. Okay. So this should still work as expected, correct? Yeah, I think so. I think it should still work as expected. The next thing we need to do is figure out what to do with a green colored 9, which will show up here, basically. Okay, 320 is... We read row 320, which will give us, yeah, the usual, which is that. We'll continue reading. I'm pressing tab so many times here, I don't even know what I'm doing anymore, but once the 9 gets hit, this happens. 223 gets in, just checking to make sure this works. We'll continue reading, and then we'll realize there's nothing here, and then we'll continue reading from 127. And then when there's 129, that will get thrown in and things will get really wild, right? I think so. So 128 will have nothing. 129 will have something. It will get thrown in normally. 129 will be read as a regular value. 290. And it will read there as fine as well. Okay, I'm trying to figure out what happens if I just don't do anything. Right now 129 will read 298. Correct? Yeah, I think so. 298. We'll read to 380. We'll read those values as per usual. We'll add, I think, a 0 and 1, I think, if I remember correctly. So here... No, we'll add a 0 and a 1. Yeah, we do add a 1 here. Okay. Then... we'll read all the way to the end. There'll be nothing until 389. Okay. This is where it gets really important, I think. Because it is about time to read the 129 already. So yeah, here we'll just continue reading through. The 129 becomes a 130. And now what? Will we just read 130? No. We need to go back to the previous layer. There's no point in reading row 3. So we need to check if this divides by 10 exactly. So I want a duplicate that is modded 10. And now I want to check if that's 0 or not. If it is 0, then it'll get thrown away. And this 0 will correspond to this position. So I just want this, I think. Like that. Okay. So we'll start with this value. And we know this value is going to come out eventually. So when this gets thrown in here... Oh my goodness, I might as well then do this. There you go. Okay, at 389, you know this gets thrown in. Because the ones digit is not a 0, this will continue working forward. Now, the ones digit is 0 and it gets thrown away. But before getting thrown away, I feel like there's things it needs to do. Right? We just need to, yeah, we need to activate B twice again. Okay. Okay. Yeah, I can do that. Let's move these wires around a bit. I want you to go down here. I want this to be here. And then I want this to activate you. I want you to activate B twice before you leave. Just like these two. Like that. Okay. Let's try that again. So 299. Nothing happens. 299. Now something happens. We basically get the exact same setup, which is this and this. And then we'll read from 2 again. We'll read 3, nothing. Then we'll read 4, nothing. 5, nothing. 6, nothing. 7, nothing. Alright, at this point, we are done. How do we know we are done? Oh, we don't, do we? Crap, okay. How do we check if we're done? Because at this point, the bees just release the bees, but nothing happens. That's because we only get the ones digit. It's almost as if I need to do even more checks. I need to check that we're back at layer 0 at this point. That's kind of awkward. That's a lot of steps. But we have space, so I'm not too worried about it yet. In fact, like, this was almost not working, but we barely managed to get this to work. So we're fine. Right? I think so. Okay. Okay, how do we do this? So here we're done. Here there's nothing. That is because this would have activated these to continue the chain, but nothing continues here. So I feel like after this, we still need a check, right? Yeah, we still need a check. Okay, so it's fine. We can leave some space. I'm gonna push everything onto the other side again. Just so I have enough space to work with. Yeah. This I can throw away. This needs to continue to do something. It needs to read the position, which I think will be here. Divide by 100 to check which layer it's in. And then check whether it's equal to 0. If it turns out to be in 0, which means that it is the last digit in the singular row we are checking in layer 0. Because we know it's number 9 prior. If it's number 9 and also in layer 0, then yes, we're done. Then this will activate this to get thrown out. Yes. Okay. Yeah, I can do that. And I will just get thrown away. Alright. Throw away. Wire activates, we use red. Wire activates you. You get thrown out. I basically want to check you against this guy. So you call out position 0. And yeah, 0 should move forward to the next step immediately after. One of them will multiply by -1, and we're fine. I do have an emergency for this. I think I did this before. Actually no, these will run parallel. Okay, so I sort of want this instead. But this needs to wait a bit. Like that, I think. Okay. Is it? These are calling 7, will be here. These will be here. This should be the one that's waiting. Okay. So let's keep... Ah, geez, what? What in the world? Oh, this got activated. Oh, because we started off... Wait, what? Oh, because we should read position... Okay. Here, there you go. Yeah, we should read signal 2, not signal 0. What am I saying? So this is at layer 3. Aha, okay. So going back, we'll now be at layer... Yeah, okay. So we might as well just pick to this point. Because we know this point is one of the last points we'll see. So here. At 9 here, we will then read again. We realize by in layer 0, this will activate this to run through. And this will merge. It will give you some number. And we want to know if this number is... The absolute value is between 5 or not. But how do we know which number is greater? How do we know which is the value here? We don't. The answer is we simply check 2 different ways. We either check whether it's above above positive 5 or below negative 5. And that will get it out of the range regardless. So if it's less than 5, it's tick. Otherwise, it's hash. Okay. So we check for whether it's greater than 4, which is 5 and above. And if it is, then it will get sent out. And I will do the same with less than negative 4. If it is, it will get sent out again. But if not, it will just stay true here. And in both cases, if it's sent out, it goes straight up this way. It will then have to be a red hash, right? Yeah. Okay. So we'll set it to the red hash value, which is 151. We'll make it red, because it should be red. And I know it will most likely be red because there will always be a 0 added in at some point, but just to be safe. And then for the top, here, if it passes both checks and it's in the range, we color it white and make it 144. Oh, colorless. Then we send it in. Of course, before sending it in, the final step is to reset and recall number 1 for the next step. So the answer... Oh, 1. So the answer is, does this work? So right now, we will get the value of 1, which is within the range -3, is within the range -4 to +4. So it'll go through and become a check mark. Oh, this is a checker. Oops, I meant to make it a definer. 151 here and then 144 here, right? Yeah. Okay. So final check again. Yes. Yes. Okay. And then we'll continue reading this. And then the thing should run as correct.